All right, in 13.8, we're going to look at proving that inverses are inverses of one another by using compositions. Now, this takes us way back to like the beginning of the year when we did compositions. That's when we did like f of g of x, remember? Or g of f of x. We plugged one function into each other. And we use them specifically to prove they are inverses because when they're inverses, both compositions will come out to be a positive x. They must equal x because that's that line of symmetry, right? Positive x, y equals x. All right, so we're going to look at two functions and we're going to do the composition thing and see if they come out to x. So really this is just a lot of algebra. Now one thing to look at is this first quadratic right here, 7x squared. Remember, it has to have a restriction for it to even have an inverse. So it has a restriction, and notice that this restriction is pointing to the right. So that's a positive restriction, isn't it? And look at g of f, or g of x. It's positive, isn't it? So that's a good sign. So far, so good. So since this is pointing right, and this is positive, this is a good sign. So far, so good. Now let's plug in. Let's take f of g of x. So let's write out our steps. So I'm going to take f of, and I'm going to put g of x in there, the square root of x over 7. All right, so I'm going to take that 7 times the square root of x over 7. There's my g of x. So when I square it based on the equation, now we're going to clean it up. So when you square a square root, it's going to be, everything just pops out, so it'll be x over 7. Those go away, and it reduces to just x. Okay, so far so good. Now let's switch it around. Let's do g of f of x. So I'm going to do g, and I'm going to plug f into it. So I'm going to put in 7x squared into the g function. So let's put in that 7x squared over 7. Now let's go back and clean it up. The 7s will divide out, and I'm left with the square root of x squared, which is just x. Now, since they both came out to be positive x, we are good to go. So we can say, yes, they are inverses. And we've given our algebraic proof. Look at number 2. Okay, so here's my quadratic with its restriction. Notice it's pointing right to the positive side, and my g of x is the positive square root. So we're in good shape so far. Now, we're going to go through the same process. We're going to do f of g of x. So we're going to put in g of x into f. So it's going to put in square root of x plus 1 over 2 into the f equation. So it's going to be 2 times all of this mess, x plus 1 over 2 squared minus 1. So when we square this square root, all of that's going to come out. Now we clean it up. These 2's will divide out, and I'll have x plus 1 minus 1. And the 1's go away, and it leaves me with just x. Now let's switch it around and try it the other direction. So g of f of x. So I'm going to plug in 2x squared minus 1 into g. Now g says it's going to be the square root of 2x squared minus 1. And then there's a plus 1 back here on g, right? Divided by 2. Now let's clean this up. Negative 1 minus 1, those go away, right? So I'm left with 2x squared over 2. The 2's will cancel out, and I have the square root of x squared. Again, that comes out to x. So it is proof that these are inverses. You can't just say, yes, they're inverses and hold your breath and hope it works. You have to have the algebraic proof to show it, like we just did. All right? Now, the second part of your assignment, look at this. For each, you're going to state the domain and the range of the given function and its inverse using interval notation. Now, interval notation is the one with the parentheses and the brackets and the infinities and all that stuff, okay? So what's going to be important for you to remember is that little trick we talked about with domain and range for the function and its inverse. So do you remember that the domain and the range are just flip-flopped? They're switched. They're switched for the inverses, and that really makes this a lot easier. So really what we have to do is a couple things. First, we want to find the vertex, and then you want to sketch a graph. Doesn't have to be a fancy detailed graph, but it gives you an idea. And then from there you can find your domain and range, then flip-flop them for the inverses. So let's look at this. Okay, so look at this number 3. F of x equals 3 times the square root of x plus 14 minus 5. Now, where's my vertex? Well, my vertex is at negative 14, negative 5. All right? So if I just visualize what's happening, that's down over in quadrant 3. So at negative 14, let's pretend that's negative 14 and this is negative 5. I know my vertex is right here. Now this 3 right here is just a vertical stretch. It's really not going to matter because my square root is going to just go up like that anyway. This 3 doesn't really matter. It's just stretching it. All right. So now from there I can tell what is my domain because I read left to right. So it's the furthest left it gets is negative 14, and then it goes all the way to the right to infinity. It does get the hard bracket at negative 14 because it's a solid dot, and it goes to infinity. Now the range from bottom to top, it doesn't happen until negative 5, and then it continues going up. Now to get the inverse, the domain and the range of the inverse, you just flip-flop them. Remember, the range becomes the domain of the inverse, and the domain of the original is the range of the inverse. So I just really flip-flop them on my paper, and I'm done. Let's try number 4. All right, look at this one. Where's my vertex this time? Well, my vertex this time is at 3, 6. Okay, that's quadrant 1. So 1, 2, 3, and let's pretend that's 6. So here's 3, 6. Now this negative does matter here because it's a reflection, right? That means it's going down, and that would affect my range, wouldn't it? So stop and think about it every time. Now domain, we go left to right. And it starts over here at 3, where x is 3, and goes to positive infinity. So we'll have the hard bracket to start, and it goes with infinity with a parenthesis. Range will go bottom to top. So remember, domain is left to right, bottom to top on range. So bottom to top. Notice it's going to negative infinity, and it stops at 6. Now, once you know your domain and range of the original function, you just reverse them for the inverses. So my domain of the inverse is going to be the negative infinity to 6, and the range will be the 3 to positive infinity. All right? Hope this makes sense, and you're beginning to see some patterns. All right? We will see you in class.